Hello students, welcome back to geometry. Today we are going to be discussing section 5.6, which is the ASA and AAS congruence theorem. Now, since we've been working in this chapter, you can probably guess that ASA stands for angle, side, angle. The way this works is if I have two triangles, let's see if we can make that one a little less isosceles. That's better. I'm just going to copy this real quick so they look congruent. We'll label these A, B, C, D, E, F. In order for angle, side, angle to occur, we have to have two sets of corresponding angles. So that would be angle B and E, and then maybe angle C and F. And then we say ASA because the side is between the two angles. So the side that has to be congruent has to be the set of corresponding sides that are between the two angles. Now, if we can come up with this situation, that implies that the two triangles are congruent. So we can say if two sets of corresponding angles are congruent and the corresponding sides between them are also congruent, then those triangles are congruent. That is the ASA congruence theorem. Now, in a similar way, we also have the AAS congruence theorem, which works almost in the same exact way. Just label these. We'll say A, B, C, D, E, F. And in this case, what we have is two sets of corresponding angles are congruent. But in this case, it's one of the other sides. So for example, right here, side AC and side DF. I could also have this work here. That would be SSA because I'm going side angle angle, but that still works. So in this case, I would say if two sets of corresponding angles are congruent and one of the other sets of corresponding sides are congruent, then those triangles are congruent. And that is the last congruence theorem of this chapter. So, just a quick summary, move off to the side for a moment. We have some theorems that work to show that triangles are congruent, and we have some theorems that do not work. So, to summarize the ones that we've learned, we have learned that SAS is one of them that works. SSS, HL, I'm going to put a star right here because this is only for right triangles. And then today we learned that ASA will work as well as AAS. So you have 5 different ways to prove that two triangles are congruent. Now there is something you should remember is that there are 2 of them that do not work. So if I have AAA, that will not work to show that two triangles are congruent. If you have angle side side, angle side side does not show that two triangles are congruent. So remember, you have these 5 right here that do work and these 2 that do not work. So let's see how these work in a proof. So in this one, AD is parallel to EC, BD is congruent to BC, and I want to prove that those two triangles are congruent. So we'll just start off with AD is parallel to EC, and that is given. Now, once I see that two lines are parallel, I should immediately be firing up my parallel lines vocabulary. Alternate interior, alternate exterior, consecutive interior, consecutive exterior, corresponding angles. I should be thinking of all of those. What I see is I've got these two parallel lines, and then I've got this transversal DB. What I notice is right here, I'm going to draw this off to the side. Here are my parallel lines, and then here's the line cutting through them. Angle D would go right here, and angle C would go over here. So step 2, I can say, since those lines are parallel, angle D must be congruent to angle C, and that's because of alternate interior angles. So that's an angle. Step 3, oh, I see that I've got these sides here that was given. So I can say BD is congruent to BC. That one was given. I could have said that one earlier. And now the last thing is I notice I've got some vertical angles right here. So I've got a side there, and then step 4, I can say angle ABD is congruent to angle CBE. The reason for that is vertical angles. And there's angle side angles. So now that I have that, I can say triangle ABD is congruent to triangle EBC because of angle side angle. Let's do one more example. Okay, so in this case, we do have parallel lines again, and we have got angle F and angle K are right angles. Now, anytime I see right angles, I should immediately think, okay, these are right triangles. Can HL work? Sometimes yes, sometimes no. Let's see. Okay, so step 1, HF is parallel to GK, and that is given. Okay, so again, if I've got parallel lines, I should start thinking about all of my different parallel line vocabulary. So I should look at these two parallel lines, and then there's the transversal. And I see here's angle FHG, and here's angle HGK. Those would be my alternate interior angles there. So step 2, I can say angle FHG is congruent to angle HGK because of alternate interior angles. Okay, step 3, I can say angle F and angle K are right angles, and so therefore angle F is congruent to angle K. This one is given, and then this one is definition of right angles. They're both 90, so they must both be the same. So now I've got this angle is congruent to this angle, and then I've got this angle is congruent to this angle. So I've got my two angles, and so now I need some kind of side in there. That way it could either be angle side angle or angle angle side. And hopefully this one jumps right out to you, is that this side right here is congruent to itself. Step 5, HG is congruent to HG, and that is because of the reflexive property. And so now I've got angle, angle, side, so I can say, step 6, triangle HFG is congruent to triangle GKH because of angle, angle, side congruence.